Hello, and welcome to the homework review. Okay, so problem one was what is the value of 8 times 4 plus 2 minus 8 plus 4 times 2? Okay, this one is very easy. So 8 times 4 plus 2 is 34, and 8 plus 4 times 2 is equal to 16, so the answer is 18. Okay, let's move on to problem two. Okay, so this one is also really easy. So we can just visualize in our head how this crease is going to like fold here. So we get our answer is E. Okay, so to solve this okay, so wind chill is a measure of how cold people feel when exposed to wind outside. A good estimate can be found using this calculation, where the temperature is in degrees Fahrenheit and the wind is approximated in miles per hour. So we have to approximate the wind chill at 36 degrees Fahrenheit and 18-degree mile per hour wind. So to do this, we just have to do 36 minus 0.7 times 18 is equal to 23.4. So the answer is B. Okay, so for this one, we have some numbers in a spiral, and we have to see which of these are prime. So one way to do this is to just fill in the whole spiral. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Sorry. 40, 41, 42, 43, 44, 45, 46, 47. So we have that 19, 23, and 47 are prime, so our answer is 3. So there are 250 trout in a lake, and a marine biologist catches and releases a sample of 180. 30 are identified as trout. So the ratio of trout to the total number of fish is the same. So we have to find out how many fish are in the lake. So 30 over 180 is 1/6. So 1/6 are the fish of. So 1/6 of the fish are trout. So 1/6 of x equals 250. So x is equal to 1500. So our answer is B. So in this one, we just have to use the digits 2, 0, 2, and 3 in this box. Okay, so firstly, notice that there is a 0 here. So 0 can either be a base or an exponent. If 0 is a base, then this is just going to be 0, since 0 to the anything is 0, and then 0 times anything is 0, so the whole thing is 0. 0 is obviously not maximum, so 0 must be an exponent. Now 2 or 3 can go in this box, and no matter which one we put, this is going to be 1. So to make this part as big as possible, we should keep the 3 for this one. So it's 2 to the 0 times, and then 3 squared is greater than 2 to the 3. So we just put 3 squared is equal to 9. Okay, problem 7. So a rectangle with sides parallel to the x-axis and y-axis right here has opposite vertices 15,3 and 16,5. A line is drawn through these 2 points and these 2 points. So how many points on the rectangle lie on at least one of the 2 lines? So one way you can do this is to just imagine the lines and see if they will pass through the rectangle at all. If you do it correctly, then you should see that CD passes through none of the points while AB passes through one. Or you can use the equation. So the line that passes through 0, 0 and 3, 1 is y equals x over 3. And the equation going through 0, 10 and 2, 9 is y is equal to minus x over 2 plus 10. So we can just see which points on the rectangle satisfy at least one of them. We still get it's just 15, 5, so the answer is 1. Okay, problem 8. They participate in a ping pong tournament, and each of them competed against the other three players exactly twice. Shown below on the win-loss records, one is a win and 0 is a loss. So we have to figure out Tio's win-loss record. So notice that in every round there are 2 winners and 2 losers per round. So in every column, there are 2 ones and 2 zeros. 1, 1, 0. So the first one is 0, 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, and 1, 0, 0, 1. So to make 2 ones in every column, it must be 0, 0, 0, 1, 0, 1. So it's A. Okay, Malika is skiing on a mountain. This shows her elevation in meters above the base of the mountain as she skis along a trail. In total, how many seconds does she spend at an elevation between 4 and 7 meters? So we can just draw a line at 4 and a line at 7. Sorry, that's a very bad line. So we can see that the first time is between 2 and 4, and the second time is, hang on, between 6 and 10, and the last time is between 12 and 14. So this is a total of 2 plus 4 plus 2 equals 8 seconds. Harold made a plum pie to take on a picnic. So he was able to eat only 1/4 of the pie and he left the rest for his friends. A moose came by and ate 1/3 of what Harold left behind. After that, a porcupine ate 1/3 of what the moose left behind. So, how much of the original pie still remained after the porcupine left? Okay, so to solve this very unrealistic problem, so firstly, the fraction of the plum pie, if we take away 1/4, is 3/4. And then if you eat 1/3 of something, then 2/3 is left. And then if you eat 1/3 of something, then 2/3 is left. So we just have to do this. Our answer is D. NASA's Perseverance rover was launched on July 30th, 2022. Let me change my settings. Okay, so it took 6.5 months for it to travel 292,526,838 miles. So we have to calculate this in miles per hour. So firstly, let's estimate how many hours are in 6.5 months. So there are 24 hours in a day and about 30 days in a month and 6.5 months. So if we if we calculate this, then we are going to get approximately 4,800. And so it traveled this many miles in 4,800 hours. So to calculate in miles per hour, we just have to divide 292,526,838 by 4,800. So we can just estimate this thing as 3,000,000,000 divided by 5,000,000. So we're left with 60,000. Okay, so in this one we have a large white circle with a bunch of shaded parts made from circles. So we have to figure out what fraction of it is shaded. So we can find the areas of each of these parts. So firstly, let's assume that the side length of these squares is 2. So then if this is 2, then that means that both of these are equal to 1. So the area is pi 1 squared equals pi. All of these also have radius 1, so that's a total of 3 pi so far. Now we have to add these two parts. So we just have to calculate the area of the big circle minus these two small circles. So 2, 2, 2, 2. So the area of each of the small circles is pi. 2 squared equals 4 pi. And the area of the big circle is pi. This length is 4. 4 squared equals 16 pi. So 16 pi minus twice 4 pi is equal to 8 pi. So the total shaded area is 11 pi. Now we just figure out the area of the big circle. So this is 2, this is 2, this is 2. So it's a total of 6. So the total is 36 pi. 11 pi over 36 pi is just 11 over 36. Okay, let's move on. 7 water stations are evenly spaced between the start and finish lines of bicycle race as shown below. There are also 2 repair stations evenly spaced between the start and finish lines. The third water station is located 2 miles after the first repair station. How long is the race in miles? So let's suppose that it's L miles. L miles long. So let's find where the third water station is. So if we divide something with 7 things in the middle, then that means it's divided into 8 sections in all. So the third one is going to be 3/8 long. So 3/8 of L minus. So how far is the first repair station? So if there's two repair stations, then the first one is just 1/3 of lay. So 1/3 of L is equal to 2. So now we can have that L over 24 is equal to 2. So L is equal to 48. Nicholas is planning to send a package to his friend Anton, who is a stamp collector. To pay for the postage, Nicholas would like to cover the package with a large number of stamps. Suppose he has a collection of 5 cent, 10 cents, and 25-cent stamps with exactly 20 of each type. What is the greatest number of stamps Nicholas can use to make exactly $7.10 in postage? Okay, so firstly, let's consider if he used all the stamps. So if he used all the stamps, then it would be 20 times 5 plus 10 plus 25 cents, which is equal to 5 plus 10 plus 25 is 48 dollars. So we have to take away 90 cents. So to take away 90 cents, we can just use the greedy algorithm. So 25 is going to, not 22. 25 is going to fit 3 times into 90, and then 90 minus 75 is 15 left over. Then 10 fits one time and 5 fits one more time. So we have to subtract 5 stamps from our 20 times 3. So that leaves 55 stamps. This one walks half a mile to get to school each day. His route consists of 10 city blocks of equal length. And he takes 1 minute to walk each block. Today, after walking 5 blocks, Vishnu discovers he has to take a detour, walking 3 blocks of equal length instead of one to reach the next corner. From the time his detour, what speed must he walk to get to school at his usual time? 1, 2, 3, 4, 5. Okay, so let's figure out how much time he would usually take. So he takes 10. So he would usually take a total of 10 minutes. So here he already walked 5 minutes. So he has to walk 5 more minutes for 7 blocks. So we know that 1 block is 1/10 of half a mile or 1/20th of a mile. So 7 over 20 miles is 5 minutes. So to calculate this in miles per hour, we see that to get from 5 minutes to an hour, we multiply by 12. So it's just 7/20ths times 12, which is equal to 21 over 5, which is equal to 4.2. Okay, problem 16. So we enter them into a 20 by 20 grid like this by the pattern, and we have to see how many P's, Q's, and R's appear in the completed table. So we are going to count them by diagonals. So we see that the first 20 diagonals have length 1, 2, 3, dot, 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 20. And then the other 19 diagonals go 19, 18, dot, 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 1, 18. Okay, so we have to. Okay, so the first diagonal contains just P's, the second diagonal contains just Q's, the third contains just R's, and all the way up to the 20th contains just Q's because it repeats every 3, and the 20 has a remainder of 2 when divided by 3, so it's all Q's. Then the next one is going to be after Q comes R, and then P, and then 1 is the same as 19 in a modulus of 3, so it's just going to be R at the end. So now we can just calculate one of the values. So let's calculate P. So the first P is one is a length of 1 in a diagonal, then 4, then 7 plus dot 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 plus 19, and then 18 plus 15 plus 12 plus 9 plus 6 plus 3. So this is how many P's there are. So we can just divide it into 2 parts, both of which are arithmetic sequences. So we can just use the arithmetic sequence formula. So 1/2 of 1 plus 19 times the number of terms, which is 7, and then 1/2 of 18 plus 3 times the number of terms, which is 6. Now we can do a lot of cancellation. So that's 70 plus 63, which is 133 P's. Okay, we can use a similar method for the Q. So 2 plus 5 plus dot dot plus 20 plus 17 plus 14 plus 11 plus 8 plus 5 plus 2. So this is half of 2 plus 20 times 7, and this is half of half of 17 plus 2 times 6. Again, we can just do lots of cancellation. So it's just 77 plus 57 is equal to 134 Q. So we get that the answer is C. Okay, problem 17. This one is a 3D one, so we just have to fold this into this regular octahedron and see what face is to the right of the Q. So one way to do this is we can just like try to fold it, which is kind of hard. So firstly, we can fold the 6 and 7 back and fold 5 down. Okay. Okay, so now there should be 4 points at every vertice, so 4 can wrap around. Hang on. Yeah, let me change colors. Okay, so now we just have to imagine 3, 2, and 1. So if you can imagine it, the 3 is going to have the 1 fold kind of to the right and the 2 kind of fold to the left. So the 2 goes into this gap and the 1 goes into this gap. So our answer is going to be 1. Okay, Greta Grasshopper sits on a long line of lily pads in a pond. For any lily pad, she can jump 5 to the right or 3 to the left. So we have to find the fewest number of jumps she must make to reach the lily pad located at 2023. So let's suppose she starts at 0 and she tries to get to 2023. So we want to jump right 5 times, as many times as we need to. So let's just keep jumping right 5 times and see what happens. So if we jump right 405 times, then we arrive at 2025, which is too large and cannot be covered by -3. If we jump one Okay, now we can just keep listing until we get a distance that can be covered by -3. A distance of 7 can't be covered, but a distance of 12 can. So we need 4 more jumps to get from here to here. So it's 407 plus 4, which is equal to 411. Problem 19. An equilateral triangle is placed in a larger equilateral triangle so that these 3 trapezoids are congruent. The side length of the inner triangle is 2/3 of the side length of the larger triangle. So we have to find the ratio of this to this. So assume the area of a big triangle is equal to 27. So if the side is 2/3, then the area is 2/3 squared of 27, which is 4/9 of 27, which is 12. So the area is of this part is 12. The area of the outside is 27. So the combined area of the 3 trapezoids is 27 minus 12 equals 15. That means that one trapezoid must be 5, so the answer is 5 to 12. 20. two integers are added to the list blah 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 to double its range. The mode and median remains unchanged. What is the maximum possible sum of the two additional numbers? So the median must equal 8 and the mode must equal 3 and the range must equal 50. Okay, so first let's try some ideas. So to make the range 50, we can try inserting two numbers whose difference is 50 to the left and to the right. And this does keep the median 8. And this will keep the median 8. So we just have to keep the mode 3. So that means that to maximize the sum, then we would try to use 3 and 53. Which has a sum of 56. So now let's see if we can do better. Because we could just place 53 here and place like anything else. The range is still going to be 50. So we just have to keep the mode 3 and the median 8. So the highest number we can use is number we can use is 7 because if we use 8 then now the mode is both 3 and 8, and if we use 9 or more then now 8 is not going to be the median. So the highest we can use is 7, giving us 7 plus 53 is equal to 60. Hi. Okay, 21. So there are 9 cards, each of which has the number from 1 to 9. So we have to divide them into 3 groups of 3. So the sum is in each group is the same. And we have to see how many ways this can be done in. So the sum of all the numbers from 1 to 9 is 45, which when divided by 3 is 15. So each group must add up to 15. So these are the ways to add up to 15 using a 1. So now let's consider the 1 including 2. So we need a total of 13 more, which can be with 6 and 7, 5 and 8, or 4 and 9. So for the first one, we can't use 6, 7, or 5, 8 because those are already used. So we must use 4 plus 9. In the second one, we can't use 5, 8, or 4, 9 since those are already used. So we must use 6 plus 7. In case you were wondering, the third group is going to be 3 plus 5 plus 7 here, and here it's going to be 3 plus 4 plus 8, both of which sum to 15, so we have 2 ways to do it. in a sequence of positive integers, each term after the second is the product of the two previous terms. The sixth term is 4,000, and we have to find the first term. So let the first two terms be a and b. The third term is ab. The fourth one is ab squared. The fifth one is a squared b cubed. The sixth one is a to the 3, b to the 5. So consider the prime factorization of 4,000. It is equal to 2 to the 5 times 5 to the 3. So to get an exponent of 5, we just let b equal to 2. And for the exponent of 3, we just let a equal to 5. So the first term is a, which is 5. As a check, it's 5 to 10, 20, yeah, 200, 4,000. Each square in a 3x3 grid is filled by one of these 4 tiles on the right. What is the probability that we'll get one diamond? Okay, so firstly, notice that it's impossible to contain more than one diamond. It's kind of obvious why is that. If we ever have more than one diamond, then the center square is going to have to be at least 2 different tiles, which isn't possible. So, well, we can only have one diamond at most. So that means that it's just 4 times the probability of there being a diamond, say, here. So the probability of there being a diamond in this corner is 1/4 for this one times 1/4 times 1/4 times 1/4. 1/4 for each of the tiles, which is equal to 1/64 as the probability. Not very much to say. Isosceles ABC has equal side lengths AB and AC. Not actually useful. In the figure below, segments are drawn parallel to AC such that the shaded portions have the same area. The heights of the two unshaded portions are 11 and 5 respectively. What is the height of ABC? Okay, so we're going to label some of these parts. So we'll label this part A, this part B, and this part C. So we are, so suppose that D is equal to the whole triangle. So B equals C, and A plus B is equal to D. Both of them make a lot of sense and are kind of obvious. So substituting B for C, A plus C is equal to D. Let me write this D a little better. So let's suppose H is equal to the height. So from this equation, we get that A over D plus C over D equals to 1 by just dividing by D. So A over D is equal to the square of this over this, because these two triangles are similar and these are corresponding lengths. So the area ratio is just this over this squared. So we get 11 over h squared. And then we add, so this is h minus 5 over h squared. H minus 5 over h is equal to 1. So now let's multiply by h squared. So 121 plus h squared minus 10h plus 25. That's just the square of this is equal to h squared. The h squares cancel out, and 25 plus 121 is 146. So 146 is 10h, so h is 14.6. Lastly, problem 25. 15 integers are arranged in order on a number line. They are equally spaced and have this property. What's the sum of the digits A14? So this condition just means they're an arithmetic sequence. So we can write A15 in terms of A1 and A2. Is equal to 14A2 minus 13A1. So 13A1 is from 13 to 130, and 14A2 is from 280 to 182. Sorry, it looked like a 6. Okay, so this value minus this value has to be from 241 to 250. So that means that 14A2 is greater than or equal to 13A1 plus 241. Because if we move this to the other side, it just becomes A15 is greater than or equal to 241, which is the condition. So, oh, 13A1 is at least 13. So 14A2 is greater than or equal to 254. So let's find the multiples of 14 that are at least 254. So the first one is 14 times 19. No, which is equal to 100, 230, 266, and 14 times 20 equals 280. So so 14A2 must be one of these. So then let's calculate A1. So in the first one, if A1 is 1, then we get 253, which is too much. If A2 is 2, then we get 240, which is too little. And then it's just going to keep getting smaller. So the first one is impossible. For the second one, if A2 is equal to 2, then it's going to be 254, which is too much. But if we let A2 equal to 3, then it's going to be 241, which is correct. So A2 is 20 and A1 is 3. Now we can just calculate A14. So it's 13A2 minus 12A1 is equal to 260 minus 36 is equal to 224, whose sum of digits is 8. Okay, thanks